Hi everyone. In today's video, we are going to learn how to visualize the data. We are going to make some scatter plots, bar charts, line graph, box plots, and histograms. So whenever you start working on any data, so first and foremost step is to visualize the data. All right, so again, please open up your data, script file, go to file and then open file. Go to your working directory. So for example, I have this working directory in W folder here, and that's my script file. I'm going to just select it and click open. So wherever your script file is, just select that one and open. So once you open your script file, so first and foremost step is to again set the working directory. Just run this command and that's it, working directory is set. So I'm going to clear this one, the console window down there. Just press Ctrl L, it's clear. Okay, and then you're going to run all these libraries because we have been working on these libraries. If you haven't installed these packages, so I will request you to install these packages. You don't need this probably the first package again and again. All right, so you can install tidy log package and then run the library and then deploy it again, and then GGP Plot2. So install these packages if you haven't installed the packages already. Okay. After setting the working directory, I'm going to open the data. So in our previous examples, we are already working on cross-sectional data, the MPG data, and in this lecture or in this video, I'm going to include an example of time series data. I have a time series data, and that data shows the GDP and unemployment rate of Singapore. I have saved this data in my working directory with the name of example TS. I'm just gonna open it and show you how this data look like. Say this one is the country and year 2000 to 2019, and GDP, unemployment rate, and FDI. The percentage of GDP is also given over here. So that's my data. I'm just going to close it. And the other example is test data 5. So that's a cross-sectional data. So that's a cross-sectional data, and cross-sectional data I have a cars, name of the variable, different cars, and then miles per gallon, cylinder, horsepower, and weight. That's an example of cross-sectional data. So I have these two data sets. In my working directory, and now I'm going back to my RStudio. All right, so now we have run the libraries, set working directory. I'm going to open this data. This is the name of the data. You can name the data whatever you want to. So for example, I want to name this data as CS data, and then the command is read.csv. And then this is the name of the data which is already, which you have saved this data in your working directory or R class folder. Okay, so just run this command, Control Enter, and see the data is already there, CS data. So because I have already loaded these data sets, so that's why it's showing over here. So please ignore empty cars at this stage, but I'll let you know at the end what empty car is and then how you can access this data. Okay, and then time series data, again TS data, read.csv, and this is the name of the file which has been saved in my R class folder or in my working directory. So I have opened these two files. So first of all, you can see the name of the data set. So for example, if you want to see the name of the time series data, so just write the call names is the command, and then in the brackets ts data. So let's run this command and see. Here I have a name of the data sets like country, year, GDP, unemployment, and FDI. All right, then you can also check the structure of the data, and for that you can just run write str is the function that shows you the structure of the data. Just write str and in the bracket name of the data, and it gives you the structure of every variable. For example, it says country is a factor variable, year is integer, GDP is numeric, unemployment rate is numeric, FDI is also a numeric variable. And it has 20 observations and 5 variables. Okay, so if you are interested in a particular variable, so you can also check the structure of a particular or specific variable. For example, if I am interested in only GDP, I can check the structure of the GDP like this, the str, and then the time series data, then put the dollar sign. When you put the dollar sign, it call the name of the variables. You can select it just like it will show you like this. For example, I'm going to write this command again, str, then ts underscore data, then dollar C. If we put the dollar sign, then it calls a variable. Then you can select by arrow down, by putting your arrow down or arrow up. For example, I'm interested in GDP, and then you can check the structure of the GDP variable. It's a numeric variable. It starts from row 1 to row 20, so it has 20 observations. You can also check the first few observations by this command head, and then write the name of the data, and it will show you first 6 observations of the data. See, I run this command head ts data, and it's showing me the first 6 observations of this data. You can also check the head of cross-sectional data, and then only I'm just repeating this command head cs data, and then it says cars, MPG, cylinder, HP, and WT. The first 6 observations, it's showing me the first 6 observations. Okay, so we know how to calculate the mean, median, and min, max. If you don't know, please go to my previous videos. So for your interest, I'm going to repeat it again. You're gonna say summary, and then ts data, and the variable you are interested in. For example, GDP. See, the mean is minus 1.06, then first quartile, median, then mean, third quartile, and then maximum GDP of Malaysia, Singapore is 14.52. Okay, so now let's start the graphs. So before we run further commands, I'm going to just run this one, just only this command, plot ts GDP. So let's run this command and see what it does. So it will run like this. So see in my 4th window down there, so the GDP is there, okay, and then it plots over there. So you can color this one by simply putting comma color equal red, and there is red 1, 2, 3, I think so. So you can try red 3 and see it look like this. And you can also give another argument, which is PCH, plotting character. So plotting character starts from 1 and it goes to 25. You can try a different one. I like 20. It looks like this. Okay. So you can plot this scatter plot of your data. So in scatter plot, why it is important, the scatter plots are important in your data visualization. So when you have a data, you can visualize your data, which point is in the pack and which point is out of the pack. Probably in the coming videos, I'll be talking about the outliers and stuff like that. If you see, if any point is out of the pack, out of the normal range, then you might want to look into that one. Okay, so for example, over here, I have one point over here that seems a little bit outlier, but in actuality it is not. It is in the pack, but you might have some, really odd values. So scatter plots help you to see your data at first stage. So always, whenever you start working on your data, start working on checking the structure of the data, then head of the data, column names of the data, then summary of the data. Okay, and then go for plotting the scatter plots. Scatter plots and histograms are most important in your data visualizations. Okay, so this is how you plot this one scatter plot. You can also make histogram of GDP by this command hist and then ts data $GDP. So this time I'm putting color sky blue. So we have this one over here. All right, you can also make a line graph over here. So how? Just you put type L. If you put type L, then it means you're going to make a line graph. Again, plot, and then ts data $GDP, and then type L, and let's see what happens. See? So they have the RStudio have run this command and make a line graph of the GDP growth of Singapore. Okay, so you can also add a line width, which is I'm going to add 2, and then also add color red 3. Now it's looking like this. All right, and then you can also give an option to RStudio that put this variable on x-axis and put that variable on y-axis. For example, on x-axis I want to put year, and on y-axis I want to put GDP. So for this one, I'm going to run the next command, which is this one. So remember, if the first R takes first argument as x and then second argument as y. So plot x and y. So you can choose your own variables according to your data. So you just need to put your data and then dollar and then the name of the variable x and then the name of the variable y. Okay, so I want to take year on x-axis. So that's why I put years on the first, and then I want to take GDP on my y-axis. So that's why I put GDP after years. So rest of the commands remain same. Type line width 2 and color red 3. Let's run this command. See, now I have year on the x-axis and GDP on y-axis. All right, and then what happens if I put the PCH? So PCH, if I put PCH, it will go again like that, and then I can put year on again by x-axis and GDP on y-axis. All right, so what if I want to put the names? I want to name the labels like x labels and y labels. For example, ts data $year on my x-axis. It doesn't look sophisticated. If I want to only put year over here and only GDP on my y-axis, I can also do that. So for this one, I'm just putting, actually what I'm doing here, I'm just hitting enter here. So see, hitting enter. Why do I hit enter here? Because if I don't hit enter, then the command will be too long and it will be out of the sight. I want to keep all the commands into my size, so that's why I'm just hitting enter, and then if I hit enter over here, then I can do the same wording. So don't forget to put these commas. So the comma is over here, then plot year x and then data GDP as my y variables, and then type is L, line width again 2, color red 3. So here is the label comes x label. So x label in the inverted commas year, and then y label in the inverted commas GDP growth. Main means the title of the main. Okay, so it's Singapore GDP growth. All right, so let's run this command by hitting Control Enter. See, so now you have on x-axis year, on y-axis GDP growth, and on main as Singapore GDP growth. All right, so you can change this L to B, O, L, small s and capital S. These are the different types of line graph. So if I put O, then it will make some points as well. So let's run this command and see what kind of points it makes. See, now it's gonna make some points. All right. So if you want to put another line on this graph, for example, I want to see how the unemployment rate is also behaving with the GDP growth. So I'm going to stay with this one and then only add lines, then time series data, again the data I want to put, and then year, the same variable, year in the above one, the same variable is down again, and then rather than putting GDP over here, I'm putting unemployment rate and changing the color of the line. So the unemployment rate will have a blue color. So let's run this command. Now I can see the blue line over here is there. So I can see that if the GDP is down there in, for example, this is 2007 or 8 or 9. So in 2009, let's say in 2009, the GDP is too low, and right after that, the unemployment is at peak. So it means there is a relationship between GDP growth and unemployment. We can say that by looking at this graph, if GDP is going low, the unemployment is going high. All right, so you can also make some bar graph or bar plots. You do that simply, then the name of the command is bar plot, and then one variable and then second variable. Okay, so that's your time series data, and then dollar GDP and then dollar unemployment rate. I want to make these two graph. So let's run this command and see. All right, so this is the graph, bar graph. Okay, so by looking at this graph, it's a little bit not clear which one is, actually it's absolutely not clear which one is unemployment rate and which one is GDP. So what you can do, you can assign some colors to differentiate which one is your X variable and which one is your X2 variable or second variable. So let's run this command again, but at this time I'm giving the color command as well. So comma, the color, see, the first green means I'm talking about GDP, and blue means I'm talking about unemployment rate. So let's run this command and see, the green color is GDP and the blue color is unemployment. So here you can see the GDP is too low. Okay, and the unemployment is also too low. All right, and there you can see the GDP is too high, the unemployment is getting better. I mean, the people are less unemployed at this stage, and at here the GDP is also low, but the unemployment is at the top. Okay, so you can also label this one X lab and Y lab, just like the above example. So just put comma. I'm just copying this syntax and then pasting over here, and then putting here comma, at this stage comma, hitting enter, and then running and putting the X lab and Y lab and then main. Right here on this one, GDP and unemployment rate on y-axis, and this is my main title. Okay. All right, so for example, now you want to put the legend. So you want to say over here, you in the corner, you want to nominate that which color is showing which variable. So you can run this command, and then you can run the legend, then top right. So it means legend top right. You're putting, you want to put the legends on top right at this corner with GDP and unimp is the name of the variable I'm going to put here. And remember, this green should match this one, green and blue and blue. So it means green means GDP and blue means unemployment. So if I run this command and let's see what happens. See, Now I got the legend over here at the top right corner, the GDP and unemployment. All right. Okay. Please ignore this command. This command actually will give you almost similar result, but a little bit will be different than this one. So let's run to just to see. See, it has run another command. It has given us another legend GDP and unemployment. This time rather than saying unemp, I only have mentioned UN over here. So what is X and what is Y? Actually, it's if you go to the quartiles, the 4 quartiles, and then if you point out X and then point out Y, then it will come something over here, a point something over here. If you want to change this one, you can change these X and Y's and change the position of the legend. So you can also change the position of the legend. If you want to say top right, you can also say top left. But you have to run this command, earlier command again. See, this is the bar graph I got, and then legend, and this time it is on the left. Again, you can change the position of your legend by changing X and Y values. All right, so I have shown you already the histogram, and then histogram of unemployment rate. And then you can also name again XLab and then main and then color. So for example, I want to see the histogram of unemployment rate. Hist is the name of the command, and then time series data $unemployment rate and then comma XLab main color. Just run this command. See, it's over there. All right, and then the next one is really very useful command, which is box plot. So box plots are usually, we see the box plot to see the range of the data and the mean of our variable in one graph. We can see that how by running the box plot. For example, this is the command name box plot, and I want to see the range of GDP variable. So let's run this command. I'm gonna show you what it does. So see, I can see the range of the GDP starts from lower than 0 and maximum goes below 15, and somehow 4 point something or around 5 is the mean of the GDP. Okay, so for example, if you want to see the similar thing for CS data, so let's write CS data and miles per gallon variable. See, the miles per gallon variable says the mean is around 20 and maximum is around 33 and the mean is around 10 point something. All right, if you are not sure, you can check this one by running the summary command. See, mean is 10.40, max in 33.90, and mean is 20.09. So these are the box plots that shows a range and mean value of your variable. So you can also plot 2 variables, 3 variables, but remember that 2 or 3 variables should be in close to one another in values or in mean values. So for example, I'm going to run two variables on one box plot. So how to do that? Just remember, just put this one box plot, then CS data, cross-sectional data, first variable, and then comma, second variables. Run this command, and you will have 2 box plots over here. Okay, so you can also change the color of the box plots by simply putting the color argument like this. See. And then you can also put the gray like this if I am checking only unemployment rate. Okay. All right, so this is how you can put the box plot. So we have covered the line graph, scatter plot, bar plot, and box plot up till now. So I also want to introduce you the GGP Plot2. The GGP Plot2 is very famous package for making graphs. It's super powerful. So I wanna just let you introduce over here. I wanna just to give you a flavor over here, because in future we might be using this GGP Plot2 package to develop our animated graphs. So you know, the moving graphs or animated graphs, we might use GGP Plot2 package for creating the animated graphs in coming videos. All right, so to use ggplot2, you're gonna install this package ggplot2 and then run this command or load this package by library, running this command library ggplot2. ggplot2 is actually is used for graphics. It's a very powerful tool used for graphics. Okay, and it has normally four arguments. The first one is data, and the second one is aesthetics, and the third one is geometry, and the fourth one is facet. Data means data that you want to use, and then aesthetic means you're gonna give x's and y variables to ggplot2 command, and then geometry means what kind of geometry you want to use. For example, geom bar or geometry line or geometry bar graph or geometry what. And facet means that if you want to make some graphs based on some groups, so you can use that facet argument to mention or to differentiate the groups. Okay. Let's run this command ggplot2 ts data. So see, this one is the ts data, the first data I have given to RStudio, then comma. AES means aesthetics, and then x variable is year and y variable is GDP. You're gonna put plus sign over here instead of comma, and then geom point means I'm gonna make some a scatter plot between these two variable x and y. So let's run this command and see. Year is on this one and GDP on this axis. All right, so if I just change geom point to geom line, and then in the brackets I don't need to write anything. See, this line is almost similar to the earlier line which we have drawn by using simple command, not by using simple R base, not ggplot2 function. All right, so you can also use cross-sectional data. Over here, what I did, I used cross-sectional data, and then x is equal to mpg and y is equal to wt, and I told RStudio that make the color based on cyl variable. Cyl variable is my cylinder variable, but it has makes some, you know, graphs like light yellow to light gray to dark gray. I don't know what is it, if it is a gray or some other colors. I am a little bit, you know, color blind. Anyway, if you want to make this cylinder variable to a vector variable, then the situation will be different, and then it will make some categories over here. For example, if you want to make some, you will face in your data that you want to make these graphs based on your color or based on your other variables. You can do that. First, let's check the class of this variable. You can also check the class of the variables by using str command, sdata, and then $cyl, and then run this one. It says it's integer. You can also check the class of the variables by using class command, class. It says integer. See? So now if I'm going to change this cyl variable to a vector variable, the command is this one, simply csdata $cylinder or cyl, and then assign it to as.vector. This is the command to make this variable as vector. You can convert this variable, integer variable, to a vector variable. Okay, and then cs underscore data, then $cyl. Run this command and rerun this command, the first one. Let's see what happens this time. See, now CYL4 is different, 6 is different, 8 is different. So now we know this is mpg, miles per gallon, and this is weight. This dot belongs to 8-cylinder car, and this dot belongs to 4-cylinder car. It means if a car has lower weight, it has maximum miles per gallon. Weight is low, then miles per gallons are high. And if it has miles per gallon high, what type of cylinder it has? It has a 4-cylinder car. It was a 4-cylinder car. If it is an 8-cylinder car, the 8-cylinder cars means the blue dots, and these are fall only in this region. So it means that usually 8-cylinder cars are low mileage cars. 6-cylinder cars are kind of middle, some sort of mileage cars, and then 4-cylinder cars are high mileage cars. So these are the understanding you are getting from visualizing your data. Okay. So you can also use GGP Plot2 for creating histogram. So let's say you have created the histogram of mpg. It looks a little bit messy. I'm gonna change it it should look like the one we have made earlier by using only simply histogram. So for example, this was the histogram we made earlier. It should look like this if we go for GGP Plot2, if we go through by GGP Plot2 and make histogram. So argument is for this one is, so I have seen the bins over here. So 1 bins, 2 bins, 3, 4, 5 bins over here. So if you make 5 bins and then run this command, and you will probably get the nearest histogram of your variable. Okay. All right, and then you can also put some other colors like blue, and then color green means the lines over here, and then fill means you are filling this histogram with blue color. So if you run this command again, the mpg and with blue color, it looks like this. So these two are now very close. Okay, and that's it. This is the end of today's lecture, and now I tell you how you can actually access the data. If you write the data and then in the inverted commas empty cars. So let me first remove the empty cars data from my list. Empty cars. There is no empty cars data over here. So you can load this data in your RStudio. It's already built in. So the command for this one is data and then empty cars. Just run this command and see the data is already there. So please download or have this data actually on your laptop. Empty cars. This is freely available. You can access these cars. And MPG, cylinder, disk, HP, jack, WT, QSEC, VS, AM, gear, and grab. These are all variables of this data. So probably coming lectures we will be working on this empty cars data. If you're not sure about these variables, go to your console and write question mark and then write empty cars and hit enter. Not need to hit Control Enter down there if you want to run these commands. You only need to run a single enter if you're running the commands in console. All right, so I just have put the question mark and then empty cars, and then in this window, in my fourth window, you can see the explanation of empty cars data. So it says MPG is miles per gallon, then CYL number of cylinder and blah blah blah. All right, so this is the explanation of this data. Similarly, if you are not sure about any software any package or any command, you're gonna just simply type question mark and then say ggplot. All right, and then hit enter. And then in the fourth window, you will get the documentation and explanation of ggplot. And in ggplot, you will see the examples as well. The examples of ggplot in fourth window. See, the example says ggplot, data frame, AEX, aesthetics, XY, other aesthetics is you want to put, and then run the command. And it also gives you some examples. Okay. So similarly, if you are not sure about summary command, so just run question mark. So put question mark and say summary, object summary. See, the documentation is there. So you can see all the documentation of a package, of a command. If you are not sure of a function, simply put question mark and then name of that particular function or command or package. The data, the R will show you the documentation, and at the end you will see the examples as well. Okay, in next class, we will probably be looking at cross tabulations, missing values, t-test, chi-square test, and how you can use these tests to test the hypothesis. Actually, our goal is to HESIS, I think so. Yeah. Thesis. Excuse me. All right. So in next class, we're going to work on cross tabulations, missing values, handling missing values, t-test, chi-square test, probably not missing value at this stage. I'm gonna make a separate video for missing values in coming videos, in coming days. Actually, what we are doing, we are learning all these things to use RStudio for our thesis and for our data analysis actually part. So usually in thesis we have introduction part, then literature review part, then data and methods, and then results and discussion. And in results and discussion, we know about that we have to do the frequency analysis, then cross tabulations, then data visualization, basic graphs, and then summary of the data, and then results of your main model. So these are all things we are going to learn. In our previous video, we have learned about frequency analysis. We have also learned in this lecture about data visualization. In next class, we're gonna learn about cross tabulations, and these things actually including the summary of the data. We have also learned the summary of the data. Actually, these 4 things are called the descriptive analysis, right? So these 4 things are called descriptive analysis of the data. If you know how to do these 4 things, it means you know about doing the descriptive analysis of your data. All right, so thank you very much for watching today's video. See you next time. Bye-bye.